ahead.
Thank you, Kim. I'm really excited to be here with Jagain from WANdisco. What we're going to talk about today is talk about a modern data architecture. What is a modern data architecture, why it's important, why it's required, and how we enable it with the Hortonworks Data Platform and the WANdisco Non-Stop Hadoop for the Hortonworks Data Platform. So getting into introductions, really excited to be here with Jagain sitting next to me. Jagain is the CTO of Big Data at WANdisco, and he's been working with Hadoop from the early days, co-founded a few startups, and now working with WANdisco to bring non-stop Hadoop capabilities to solve BCP-related concerns and issues with the HTTP stack. And Jagain actually was involved in some of the early Hadoop releases. He managed the Hadoop 1.x line, 0.20, one of the earlier Hadoop releases, and so has a lot of operational and development and enablement experience with Hadoop over the years. I'm Rohit Bakshi. I'm a product manager here at Hortonworks, and I focus on platform services, so HA, DR, Hadoop Core. So really excited to talk to you and have a conversation around the modern data architecture and what we're doing around BCP with WANdisco. So let's get started. We'll start with an overview of the drivers, right? Why are we here? Why are we talking about this? Why do these technologies matter? And what is our vision of the modern data architecture for enterprise organizations? We'll talk about Apache Hadoop as the solution piece in the modern data architecture. We'll talk about WANdisco's non-stop Hadoop as a solution in the modern data architecture, and Jagain will go through the details and talk about the technology, and we'll have a really cool demo as well as part of this conversation to showcase the functionalities and benefits of the WANdisco non-stop Hadoop solution. And then we'll leave time, just like Kim said, for questions and answers at the end. So if you have questions while we're talking, please enter it into your chat box, and we'll get to it at the end, and we'll answer a lot of your questions. So let's start with framing the discussion here, right? We're talking about data architectures. Now, traditionally, what we've been seeing in the enterprise organizations and what many of you on the phone probably work with and deal with today is a simplified version here is in front of you. We're looking at an existing data architecture where you have multiple layers. You're solving the solution, the problem of having multiple different sources of data, so customer relationship management data, ERP data, data coming in from observations about your customers and observations about different processes that you have going on. You have existing sources, taking them and putting them into a relational database system to consolidate and provide analytics and reporting needs from it. So your data system layer would be any kind of relational database, an EDW, variety of NPP databases, OLTP databases, and those databases then power different analytical and reporting applications on top of it. So, we work with customers who have custom bespoke applications that are running, reporting applications running on top of that EDW. They have reporting platforms, so package applications running on top of those EDW platforms, and that's where the business users, the analysts, analytics folks work with and interact with the systems. So those are the existing data architectures that we see today. And what's happening and what's driving this need for modern data architecture is that there's pressure on this existing data architecture. And the pressure is coming from data, really. It's coming from the vast amounts of data. There was an IDC study done where just last year there's about 3 zettabytes of data that's being captured, stored, and processed in enterprise data warehouses and across enterprise organizations. And that's just today or last year, really. What we're seeing and what they saw over the next few years going up to 2020 is that there's going to be a massive growth in that data. So there's going to be a growth in the size of existing data. There's going to be a growth in the size of new data types. And new data types are types of data that are coming in that always existed, but they're now enterprise organizations want to capture. So want to capture raw clickstream data, want to capture machine-generated data. And that sort of new data that can be captured is growing in, there's 85% of the new data growth in the next 8 years will be in machine-generated data, will be in clickstream, social media sentiment data. And by 2020, we're going to see about a 15 times increase in the amount of data that's flowing in and being stored in enterprise data architectures. That puts a massive amount of pressure on existing data architectures from two different ways. There's pressure from an architectural technology way, pressure, as well as the pressure in efficiency and cost. And so those two pressure points are really driving a modern data architecture, the need for modern data architecture today, as well as to serve that growth going forward over the next few years. And that's where Apache Hadoop and the Hortonworks Data Platform comes in. It comes in as an enablement, as an additional +1 piece of your architecture to your existing data architecture that's been working very well for organizations over the past few years. So Apache Hadoop is a scalable, flexible processing and storage engine and data system that sits alongside your EDW, your MPPs, your OLTP databases, and allows you to capture new and existing sources that vary over volume, variety, and speed of data coming in. And this joint data system then enables and powers your existing custom reporting applications. You can build new applications on top of Hadoop, and that way you enable your different skill sets. And so let's now talk about let's dig deeper into some of the drivers of Hadoop adoption. There's two drivers that I had outlined before, and I want to dig into a bit. There are new business applications, and what I mean by that is there are new types of data that have become important to organizations and also possible to capture that are now driving new business applications. We'll go into a few examples there and what are some of the needs around Hadoop and enterprise-ready Hadoop. And then there are architectural drivers. Efficiency, the ability to incorporate these new types of data and store and process at scale. And those two sets of drivers are really why Apache Hadoop becomes a piece of the solution. So let's talk about, let's dig into some of the new business applications and drivers. And so here we have an example of data that's always existed, but now is becoming an important part of decision-driven BI and decisions at the business level, right, at the executive level. There are examples such as sentiment, capturing all different aspects of customers or economic trends, or understanding the feelings and the needs and the thoughts of your customers across, web report forms, across social media, across their interactions and their interactions across mobile phones, and storing all that data inside your data system, and then being able to report and analyze on top of that. There's clickstream sensor machine-generated data where you have systems that are outputting millions of events every single day, and there's a lot of data that needs to be stored in your data platform and then mined through and processed and refined to find value in that. So these are examples. Server logs is another example. Geographic data is now being incorporated into decision-making processes. All this new data needs to be stored at the most granular level at times, because that's how you can figure out what needs to be, what's of value. It needs to go through your processes that are running every single day. And so this opportunity to drive new business applications, it requires a new type of data architecture, including Hadoop, and it requires that data architecture is constantly available, is resilient to failures, and is able to function at scale, because that's what the opportunity kind of drives from a technology perspective. And so to dig into some of the requirements for Hadoop adoption in an architectural and technical angle, there's three that I see that kind of drive how you view an enterprise-ready Hadoop distribution, right? It needs to be integrated, interoperable with data center investments and data systems investments that you've already made in your organization, so you enable the modern data architecture. It needs to be leveraged and work with skill sets that you have in your organization, so that people that you've invested in or people that are working in the IT organization can leverage this as a +1 and not have to relearn and redo everything. And it needs to provide key services, and I'll go into some details there, to ensure that you treat Hadoop as a +1, the same level of trust and the same level of, you run the same level of mission-critical applications and analysis in Hadoop that you would do on your EDW as well. And that's really why we're excited to partner and work with WANdisco to enable those services. So let's dig into what those mean. From a key services perspective, and what I want to focus on in this, and what we'll focus on in this webinar, are platform services. So platform services such as high availability, disaster recovery, the ability to recover and deal with different failure scenarios that occur in data centers, that occur in database systems, right? Ensure that an enterprise-ready Hadoop distribution, like the Hortonworks Data Platform working with WANdisco, allows you to trust storing critical data, trust that Hadoop is the single source of some of that very granular data that you're capturing across your enterprise, and using that for driving analysis and enterprise business analytics. A Hadoop distribution needs to also ensure that it has the ability to deploy all these services and capabilities across, in an easy-to-use and packaged format. And it also needs to enable that you really enable the Hadoop as a distribution, as a platform, right? So Hadoop and HTTP, the Hortonworks Data Platform is a collection of different components that come together to enable the ability to store, process across different dimensions, serve up data, monitor and manage. All of those features of a platform are all built into the package. That package needs to work with existing skills. And the way that we do that is we ensure that, you know, your operational folks, your data analysis folks, your developers who are working in the enterprise organization can use existing tools that they're comfortable with, and those existing tools work with the Hortonworks Data Platform, the Hadoop distribution across a variety of very standard APIs and interfaces, be it NFS-loaded data in and out to HTTP, be it WebH catalog to submit jobs and to run processes, be it ODBC drivers to pull data out of HTTP. All these different ways of interacting with existing solutions are built in and certified against the Hortonworks Data Platform. And that's what enables the integration, right? The Hortonworks Data Platform and Hadoop, Enterprise Hadoop, is a +1 addition to your existing investments, and it integrates well with your ecosystem to provide you the requirements and the functionalities you expect from enterprise-ready Hadoop distribution. And when we think of business continuity planning, and when we think of disaster recovery, high availability, that's where the Hortonworks Data Platform with the WANdisco Non-Stop Hadoop solution solve those needs, and Jagain will go into the details there. And it's part of this one modern data architecture. So the two solutions together plug into all the other existing investments you have in your infrastructure to enable the overall end-to-end modern data architecture, to enable you to develop new business applications and be efficient in how you deal with your transformation, your business analysis needs in your IT architecture. So what I'm really excited about delving into more detail with Jagain is around the benefits of what WANdisco Non-Stop Hadoop does with the Hortonworks Data Platform 2.0, and so we're certified with the Hortonworks Data Platform 2.0, which is the exciting yarn-based distribution that we rolled out just a month ago. So with the Non-Stop Hadoop solution, right, you'll have continuous uptime with no data loss across your clusters. You'll have the ability to span your clusters across geographies, which means you can write and load data from any, across, and you can load data in from New York and London at the same time. It's available across the globe. You eliminate some of the bottlenecks, and you enable load balancing, and you enable a wider set of processing and input capabilities because you have you have a distributed active namespace and workspace across clusters, and it solves a lot of the challenges around backup, failure from different scenarios, the ability to load data in at Latin speed rates. And so with that, I'm really excited to turn it over to Jagain, who will drive us into understanding WANdisco technology and show you a demo.
All right. Thank you, Rohit. Good morning, good afternoon, folks. So WANdisco is a memorable name, but it actually is a sensible acronym for Wide Area Network Distributed Computing. And that's our core intellectual property. All of the functionality that we provide is enabled by this core intellectual property, and I will go into that in a little bit more detail. We're actually listed in the London Stock Exchange. We had a hugely successful IPO in June of 2012, and the IPO was based on our success in using our wide area network distributed computing technology in the software development tool space, specifically Subversion. We have a replicated Subversion solution that's widely popular in that marketplace. Once the IPO happened, we took the proceeds and built our technology into Hadoop, and here we are providing the same levels of availability and functionality in the Hadoop space. We have US patent allocated for our active-active replication technology. It was granted to us in November 2012, and we're a truly global distributed company with locations in San Ramon, Sheffield, UK, Belfast, Chengdu, Tokyo, and Chennai, India. Here's a colorful slide showing all of our customers, and you'd probably see most of the Fortune 500, Fortune 100 in this list. They use it mostly for software development tools at this point, but we're growing in the big data space as well. So our overarching theme is this. We're enabling global protection against data loss, downtime, loss of intellectual property, loss of revenue, time to market, falling behind the competition because of outdated technology. We primarily solve the problem of coordinated storage and access to data across multiple data centers, fully continuously available Hadoop across data centers, resilient to failure of single nodes, racks of nodes, entire data centers, entire WAN links, and so on. Non-Stop Hadoop. In simple, we extend HDFS across data centers. It's a single HDFS namespace that spans multiple data centers. It's 100% continuously available Hadoop, built as an extension on top of standard Apache Hadoop HDFS, certified against HTTP2 for use in the Hortonworks Data Platform. We are 100% Apache compatible because we are indeed Apache. That means you can run Hadoop applications unmodified on top of Non-Stop Hadoop. Applications can run in any data center. You can ingest data in any of the data centers that participate in the Non-Stop Hadoop, and they're all active. There is no notion of a passive backup or a disaster recovery site where you have 50% of your hardware essentially idle. This is not a simple mirroring or a copying solution. It's a sophisticated, distributed, coordinated, multiple active data center, multiple active name node within a data center solution. The core of our intellectual property is this piece of software which we call DCONE, stands for Distributed Coordination Engine. It's really the only mathematically proven WAN-capable Paxos implementation. Paxos is this mathematically sound way of doing distributed computing, and it was enhanced by us to work over the wide area network. That's the specific area where we have a patent. It provides active-active in all locations for both create and modify operations. So you can ingest data, which would be creating files, adding blocks, closing files, deleting files, deleting directories. You can do these operations on any of the data centers that are part of the Non-Stop Hadoop cluster. There's no restriction on the distance between data centers. This is an important distinction because we have solved the problem that most other solutions so far impose restrictions on. For example, if you have block replication solutions, an example of that would be EMC SRDF, you would find that they impose a 50-mile or so, essentially a metropolitan area network limit on their solution. The reason is that they replicate at the block level, and file systems such as ext4 and FAT or NTFS don't really know of the replication, so they're not able to adjust accordingly. So we are the only solution that can work across continents, across data centers distributed around the world. I'd like to start by taking a brief look at an alternative that often companies use for doing distributed Hadoop across data centers. The utility is a simple utility called DistCP. It was modeled after the Linux utility rsync. It's the most common solution for recovery and DCP across data centers. It's offered with various user interfaces. One of the severe disadvantages of this system is that it runs as a MapReduce process and takes up slots in your compute framework to do its work. It also has an inherent problem where it skips files that are either in use on the source Hadoop or the destination Hadoop. This causes the two file systems to diverge over time. Essentially, you have a problem of several petabytes of data where 99.9% of the data is the same, but 0.01% may be different. Identifying those different files is a hugely complicated and sometimes impossible task, which devalues the solution greatly. Also, there is no possibility of running the parallel data ingest or using the backup data center for anything other than read workloads. So Non-Stop Hadoop over the wide area network provides you continuous availability. It's a single Hadoop cluster across multiple data centers. It delivers 100% uptime. Metadata, which is what is stored in the name node, is basically synchronized in using our distributed coordination technology inline. It removes the performance and availability considerations of a single active name node in one data center. All name nodes can be written to and modified. The file system is fully active on both sides. You can have 100 web servers, and you can be grabbing in one data center and 50 in another data center. You can be grabbing web logs from those using Flume or whatever and writing those into HDFS in data center 1. At the same time, you could be grabbing from the other 50 web servers in data center 2. You don't have to do data ingestion over the wide area network. You have, with some really sophisticated technology and configurations, the ability to do LAN speed data ingestion and processing on the wide area network. And naturally, because of our multiple active servers, you can have Hadoop scale as the workload increases. A brief look at how our wide area network coordination works. I will not go into too much depth in this. We have white papers and other information on our website. You can contact our staff to get more information as well. Basically, how our system works is that we do not modify the namespace first. We make proposals to modify the namespace, and the distributed coordination engine works by majority quorum, will accept the proposals and sequence a set of transactions. In this page, in this slide, you can see transaction 172, 173, etc. And once the transaction is accepted, all standalone name nodes, shared nothing name nodes, accept those transactions and apply them in the same sequence. Let's say for the moment that name node A is down. All the other name nodes in the two data centers continue to operate. Name node A, of course, is stuck in transaction 176. After a while, the network fixes itself or something happens, name node comes back to life, automatic recovery takes place. It stays in read-only mode or stays offline till it catches up with all the transactions, and then when it does, it starts providing service to clients. Note that clients can connect to any of the name nodes and get service. So if there was a client that was connected to name node A that went down, it would immediately reconnect to another client and proceed without any interruptions. No exceptions, no need to restart jobs. Let's say now that the entire wide area network link goes down or the entire data center goes down, let's say Hurricane Sandy took out a whole data center, you still have the capability to run your application in data center 2. Ingestion moves to data center 2. There is no interruption in your service at all. After a while, when data center 2 comes back, as I pointed out earlier, all the name nodes in data center 2 will catch up with the transactions in data center 1 will catch up with the transactions in data center 2, and asynchronously following that, the data blocks will also be transferred to the data nodes. Replication counts will be matched, and you're fully caught up and functional across both data centers. This automatic recovery requires no administrator intervention, and as I pointed out, is mathematically sound and well proven from 5 years of operating in the SDN world. So with this, what I would like to do is hand over to Brett Rudenstein. He's our senior product manager, and he has this wonderful demo that will demonstrate all the capabilities that we just delved into.
Thanks, Jagain. And I am just going to share the application here.
Perfect, Brett, we can see it.
Great, thank you. So today I'm going to be doing a demonstration of our Non-Stop Hadoop technology on top of Hortonworks HTTP2 platform. This will be a live demonstration across a geographic distance of about 3,000 miles. So if you look at this graphing application where you see a live view of the data centers, and I have 2 data centers. I've got one in Northern Virginia, and you can see it has 3 healthy name nodes, and then another data center in Oregon also with 3 healthy data nodes. Now to do this demonstration, I'm going to take a deeper look inside, and what we see is that we see each of the graphs representing one of the name nodes in all of the data centers. So I've got 3 name nodes in North Virginia, 3 name nodes in Oregon, and the graphing application is showing us essentially the RPC bytes in and out. So it's showing us how busy each one of the name nodes are. Now, to perform this demonstration in our Northern Virginia data center, I'm going to run some of the standard sample applications that ship with Hadoop. So we'll run TerraGen and TerraSort to put some data into HDFS and sort it into a total order. And then I'll also, in our Oregon data center, then run TerraValidate to prove that all the data made its way across. Of course, we're going to throw some complexities at the system while we do this. We're going to reboot some of the live and active name nodes, both in the local site of ingest and where we're replicating to. And at some point, we'll also bring down the entire WAN link and still provide that continuous service that Jagain spoke of. So in our Northern Virginia data center, I'm going to do the TerraGen and TerraSort. So I have a small script here, and we'll just call it Webinar 1. That's the input directory. And our script starts by running TerraGen. So one of the first things that you'll notice is that all the name nodes start responding to the requests, and that is because all of the name nodes are active. They are all able to take requests from the clients, and we are now going through the TerraGen process. Now during this process, I'm going to reboot one of the name nodes. So let's start by rebooting, we'll SSH into Data Center 1's name node C, and I will reboot that machine. And that machine has now gone down and is no longer offering any service. Now, you're also seeing these things here in the Oregon data center called foreign blocks. A foreign block is an HDFS block essentially that has not yet been replicated from its site of ingest. So because we're running our MapReduce job in the Northern Virginia site, these are the blocks that are making their way across the wide area network. So let's also cause a remote failure of a name node. I'm going to SSH now into Data Center 2's name node. Let's just pick C to keep them in the same location visually on the screen. And so I've now rebooted 2 of the 6 active name nodes that I have. But of course, if you look at the job, we've completed the TerraGen. We're now in the TerraSort phase. There's been no interruption of service, despite the fact that I've done essentially what you'd think of as the unthinkable, which is to kill an active name node during a MapReduce job. We've also done this across multiple data centers. Now, the next part of this demonstration, we'll take a look at that self-healing process that Jagain described. And that is, right now, the two name nodes that are down are offline. They're going through the reboot process, and they've gotten far behind in that global sequence of operations. I can see it just coming back. So I'm going to open up the web interface to Data Center 1's name node C, and just hit refresh here. And what you see that it says here on screen is that safe mode is on, and that currently it doesn't know who the block replicator is. So in other words, this name node is currently not offering service. Any client that tries to hit it will immediately be redirected to another active name node. While it learns from the other name nodes that it's behind in that global sequence of operations, it will play back all missing transactions and then become an active participant in the cluster again. So let's hit refresh one more time. So here we are, safe mode's still on, so it's now gone past the, it's found out who the block replicator is. It sees that there's some number of transactions that it still has to catch up on, and in just a few more moments it'll be automatically turned off and become again that active participant in the cluster. So let's go ahead and hit refresh one more time, about 4 more seconds here, and then our name node is once again active. So as both of those name nodes came back up and online, we have completely restored all missing transactions for all the name nodes that were rebooted. Now we're going to throw one more error condition at the cluster. I'm going to run again in the Northern Virginia data center, this time putting in a second directory, the TerraGen and TerraSort applications. Only this time I'm going to crash the entire WAN link, or essentially shut down the tunnel between the two data centers. So once again, you start to see all the name nodes respond to the activity. In just a moment, you'll also start to see foreign blocks appearing on the Oregon side. And what I'm going to do is issue a command, this service IPsec stop at the bottom of your screen, which effectively shuts down the tunnel between the two data centers. So what it will look like visually is that all of the name nodes immediately stop responding. Really, they've just been severed. They're still, from the current application. So they are still running in their respective data center, but they are not offering service, at least not from this side. And so we can see that we're no longer replicating blocks either, because again, we can't reach that. The link between the two data centers is down. In fact, from a visual perspective, if we go back to the graphing application, we can see that the link is down between the two locations. However, we still have service in North Virginia. And of course, if we look at the MapReduce job that's running on the screen, it is still continuing without any interruption. So let's restore that link. And what we'll see is that immediately, once the link is reestablished, we begin processing transactions, all those transactions that were missing from the name nodes that were unavailable. You'll also see that block replication will start again and will continue. And this is because we're not doing a mirroring technology, a trick, if you will, by trying to make two different Hadoops look like a single cluster, but rather we have one cluster that is spanning multiple geographic territories. So the last thing I'm going to do here is I'm going to run TerraValidate in our Oregon data center. TerraValidate, and we'll do against the first directory because all those blocks have finished, webinar 1. TerraValidate essentially creates one map task per file. So if there are any missing blocks that haven't made their way across the WAN, then we'll get a TerraValidate failed message based on the application here. But what you'll see is that all those blocks have gone, despite the fact that we've had several interruptions of both name node service and WAN service. And one other thing that you'll get to take a look at here is you're starting to see foreign blocks appear on the North Virginia side, even while we were running a job on both sides of the equation, if you will. What you're seeing is multi-data center ingest. So what this solution allows you to do is provide continuous availability of Hadoop across multiple data centers, so you can do things like global clickstream analysis, global log analysis. You can fully utilize cluster resources and of course meet any kind of regulatory compliance if you're in an industry that has strong disaster recovery requirements, not just to be back from a particular disaster, but also to be back in a relatively short amount of time. And in the case of Non-Stop Hadoop, because the environment is active-active, because both sites are able to work, if one site is unavailable, your effective downtime is 0. And so as we come to the end of the demonstration here, you'll see that our TerraValidate script over in the Oregon Data Center is going to give us a nice TerraValidate pass message. And at this point, that will conclude the demonstration, and I will pass it back to Jagain. So thanks for watching.
Great, thanks, Brett. Let me just pass the center over to Jagain. Go ahead.
Thanks, Brett. That was a very nice demo. So to reiterate, Non-Stop Hadoop, the architecture is non-intrusive. It's not simple mirroring or a copy. You will notice that all mirroring solutions require you to have an idle data center full of machines that's basically wasting electricity. We don't do that. Both data centers are always active. You can ingest data in any data center. You can run jobs against that data in any data center. Should the whole data center go down or the WAN link go down, you're still fully functional. That's the level of business continuity that we offer. We do not modify Apache Hadoop. We run on HTTP 2 or later. We're certified to run on HTTP 2 or newer. And the continuous availability we offer also comes with the additional benefit of load balancing across all name nodes. And finally, key takeaway, the disaster recovery aspect ensures that data is as current as possible. If you need a shorter window where foreign blocks are replicated, just increase the bandwidth of your WAN link. So depending on the service requirements, you can tune the bandwidth of your WAN link. There's no need to have any distance limitations because we can work across the world and we can work with multiple data centers. Virtually zero downtime to recover from regional data center failure. We provide full support for all regulatory compliance that you may have. Load balancing ensures that the workload for the name nodes is distributed across data centers, across name nodes. All your data centers are always active, both read and modify operations. You can ingest data anywhere. You can run workloads anywhere. It's global MapReduce. You can actually do analysis of data that's ingested in the US using data scientists in Europe or in Asia. And finally, I'd like to leave with a point that we maximize resource utilization. There is no idle hardware in your globally distributed, continuously available Hadoop. Now I'll pass back to Rohit.
Okay, thank you. So in terms of next steps, Kim, do you want to?
Yeah, definitely. So the next steps, I know that Jagain talked about collaterals and assets. So you want to learn more about the Non-Stop Hadoop for Hortonworks. Recommend you guys to go onto their website to learn more about the solution as well as all the value prop and the benefits that goes with this solution. The good news is that you can actually try Hadoop. We have this thing called the Hortonworks Sandbox. It's a one-node cluster that you can download on your laptop and start using Hadoop as soon as possible. With 16 tutorials and partner tutorials, it's a really good start to get you on this path of becoming, data analyst, or we're calling data scientist of today. And then the third thing is, if you really enjoyed the demo and would like to kind of see more and how this can apply in your environment, I recommend you to contact us and try this out for yourself at WANdisco@hortonworks.com. If you contact and let us know how we can reach you, we can get back to you as soon as we can. So with that, I'll pause for Q&A. Let's just see. There's lots of good questions coming in for both sides. I'm scrolling down right now. So one question that came in for Ohad, can you explain a little bit more about Nox? What does Nox mean and what does it do?
Sure. So Nox was one of the components in the stack that I had shown when talking about key components of a platform for an enterprise-ready Hadoop platform. Nox is a REST gateway, a secure REST gateway. So Nox provides a level of authentication and authorization around the HTTP stack so that you have one place where developers and data analysts can run queries, load data, run Hive queries, pull data out into their reporting applications that is authenticated across you can integrate with a variety of authentication providers. And so when you think about deploying a Hadoop cluster and you want to provide authentication authorization for your enterprise users, you would have all your enterprise users go through the Knox secure gateway to access and read and write data into Hadoop.
Great. Maybe this is something we can follow up with, but I'll just ask you anyways, Rohit. How do we protect the investment in data center network given the stress Hadoop puts on the network infrastructure?
I think I'd be interested in Jagain's thoughts on this as well. I think it's around planning, right? There's a lot of best practices that we're working with our customers around deploying Hadoop, and you're right, Hadoop puts an immense amount of pressure on network architecture, but there are lessons that we've learned in deploying, thousands of nodes across different clients, and so having a conversation and a plan around what other applications are running in your network in that specific data center, how to set up your networking to share the load, how to set up your networking between data nodes and task trackers and node managers and your master services, and how to structure so that you have efficient ways to load data in with WANdisco. There's ways, you have to figure out the WAN link and all, right?
So to reiterate Rohit's statement, it's all about planning. We know that the shuffle phase of MapReduce is very network intensive, but good planning tools are available both from us and in the open source that will help you plan that. The Non-Stop Hadoop product runs map to reduce in the same data center, so you will not have a situation where there's a shuffle phase running over your wide area network. We take care of that. As far as WAN link bandwidth is concerned, you have a very simple physics problem. If you have a data ingest of a specific rate, you need bandwidth of a specific size in order to provide the data in the remote data center. We don't copy a single block of data more than once over the wide area network, and we work with most popular WAN bandwidth optimizers. So we have all the tools in place, and we'll be happy to work with you to build the solution that works for your requirements at the right cost point.
Great, thank you. Another question in for Rohit. With a globally distributed HDFS cluster, what does the architecture of the HDP stack across geos look like?
Sure, so good question. So with a globally distributed HDFS cluster, what we'll do is we'll have the HDP stack exist in each data center. So if you think of an architecture where you have two geographically separated data centers, you'll have one global namespace across that. So your HDFS cluster, you have a set of name nodes all in the same namespace that are operating across those two geographic clusters. And when you think of the services on top of that, so you think of the node manager, the resource manager, Hive, HBase, all of those services will be individual to the specific data center. So in that two data center architecture, you'll have two separate HBase masters, two separate Yarn resource managers. And so as Jagain was saying, when you run processing, that processing and MapReduce jobs or other forms of processing will all exist within that data center, one data center. But your data is synced and spread across in one namespace across both data centers. So you have data high availability, and you ensure that your processing is happening in the most efficient location where you launch your process.
Great, thank you. One other question, so I'm going down through the list right now. Does WANdisco scale to 3 or more data centers?
Yes, we do.
Okay. What about data security encryption while transferring data from one data center to another?
We do have several options for ensuring that on-wire security is maintained, and we'll work with you to meet your requirements.
Great, and I think this is for both of you, or maybe for Brett as well. Do we need to add a global load balancer between two data centers?
No, absolutely not. There is no load balancer in the past. The problem with load balancers is now you need to make a highly available load balancer, and outage and WAN link means you need a lot of buffering on the load balancer. in very short order, what you will find is that the two Hadoops, if you should use such a solution, will diverge. Then you have a problem of half a petabyte or 3/4 of a petabyte of data with 0.1% that's different, and determining what's different is a gargantuan task, both in terms of compute and WAN resources, WAN link. So no, we don't go down that path. We give you perfect fidelity because we have a single HDFS that runs across data centers, and HDFS, the file system, takes care of replication of blocks, and it knows about blocks and block checksums, and it offers you perfect fidelity there.
Great, and then this kind of goes back to you, Brett, your demo. There are two lines in the chart, green and brown. What do they stand for?
Oh, they were representing the RPC bytes in and out of the name node, so effectively the traffic going to each one of the name nodes.
Okay. One more thing. If a query is issued to the disconnected data center cluster, I assume we will receive stale results until replication recovers?
That is correct. You will have the disconnected. So the way we work is that majority quorum can reside in one of the data centers. So if you are using a follow-the-sun model, we have tools for configuring these. What will happen is that during daylight hours in the U.S., there will be a majority quorum in the U.S. data center, so data ingestion will happen at local area network speed there. In that data center, even if the link goes down, you have read and write capability and most current data. When a link goes down to, let's say, the Asia data center when it is nighttime there, it will switch to read-only mode. So you will get, for a moment or for some duration of time, you will get stale results. But once the link comes back, within short, given the limitations of physics and your WAN bandwidth link, will be able to come back up to full speed and take read and write operations.
Great. Maybe this is for Rohit. Does it need to replicate a set of Hortonworks and storage to run this, or a set of HTTP and storage to run this? I'm not sure.
So, do you want to take that? Yeah.
Sure. Storage is a single HDFS, so you will need data nodes on both sides or both data centers or multiple data centers. But the replica count can be fine-tuned, so you can have options such as start with 3 replicas in the data center of ingestion, push 1 replica over to a remote data center, and when that replica hits the remote data center, drop the count from 3 to 2 in the local data center. That way you're getting full resource utilization of a single Hadoop cluster, yet you have both high availability within the data center and continuous availability and business continuity across data centers.
Yeah. And if you're talking about the packages and deploying the packages, you deploy HTTP in both data centers. So you'd have one instance of HTTP running in one data center, another data center, and with WANdisco's Non-Stop Hadoop, you'd have a shared HDFS cluster across both.
Great. So I guess it's kind of a two-part question.
Mm-hmm.
Does HTTP run on-premise and in the cloud? And then the other thing is, can they deploy WANdisco in that environment as well?
Sure. So let me take the HTTP first, and you should talk about WANdisco. Absolutely. So HTTP runs on-premise on Linux or Windows, and then HTTP runs in the cloud as well. So we have partnerships with hosting vendors. We have a partnership with Azure and Rackspace and different, in terms of running that as a service. We also will see customers deploy HTTP in IaaS environments in the cloud, right? Actually, Brett was doing a demo. I think it was running in EC2, right?
It was running on EC2. Amazon's Virginia data center and Oregon data center is where the demo happened.
Mm-hmm.
So we run on HTTP2 in virtual machines in these 2 data centers.
Mm-hmm.
We use it for demos, our stress testing.
Mm-hmm.
It's a continuous process, and that's guaranteed to work.
Yep. So we'll support both.
Yeah, absolutely.
Great. One of his customers mainly using servers with internal storage for their entire Hadoop infrastructure.
Mm-hmm.
He's curious if you've seen anyone leveraging any sort of share block/file storage for any part of this environment.
So shared storage is not a requirement for Hadoop per se, and shared storage-based replication at the disk drive block level, the 512 byte block level, which products like EMCS RDF do, we don't require that as well. That said, it will work. If you have investment in existing shared storage of the right size with the correct SAN bandwidth and you want to run Hadoop on one of those, HTTP2 will run just fine on top of that, Non-Stop Hadoop will run just fine on top of that, and our WAN link will do Non-Stop Hadoop over the WAN just fine.
Great. Where is the data center fabric / Hadoop cluster is the WANdisco software deployed? In other words, where does it sit physically in the topology?
It is an RPM that is installed after you install the Hadoop RPMs, and it's just software that coexists with every HTTP installed. So it needs to be installed on all the machines.
So same infrastructure that's used for HTTP. Yep. You're not adding any new infrastructure. There's no forwarding hardware. Nope. There's no load balancing. Same set of nodes you'd install HTTP. You just install WANdisco. That's an add-on, really.
Exactly. And we have integration with Hortonworks Ambari following shortly, so you can manage it with the same management tools.
Great. We have time for maybe 1 or 2 more questions because we're running to 11 o'clock.
Sure.
If the WAN link goes down, can I write to the HDFS on both sides of the WAN link?
No. If you have the WAN link go down, the majority quorum will reside in one of the data centers. There you can continue to ingest data. And data ingestion from the World Wide Web, for example, can move to that data center. The other data center will essentially be in read-only mode to preserve the sanctity or the file system. Once the link comes back, it will catch up, and the file system will be in perfect order. No lost data, no corrupted file system. That's our guarantee.
Great. So one last question. Hadoop itself provides high availability. How does Non-Stop Hadoop and Apache Hadoop differs in terms of data availability?
Non-Stop Hadoop is the only active continuous availability solution. Apache Hadoop and other solutions are all active-passive. Clients may connect to no more than the single active name node in all the other solutions. We have active, high availability.
Great, and on that, we'll stop for today. Again, you guys, the recording will be available on our website by the end of Friday. You get an email from me telling you where to go to watch the on-demand recording. The presentation has already been uploaded, and I think I shared the slide with you via the chat panel on SlideShare. And I would recommend you to go and download our sandbox, and if you have any question between how you can do Non-Stop Hadoop for Hortonworks in your environment, feel free to reach out to us at WANdisco@hortonworks.com. So with that, I'd like to thank our speakers for their time and you guys for joining us. Bye, everyone.
Thank you. Thank you.